So we found some interesting things. First of all, out of these 206 pairs of paper, each pair had 86% similarity. So very, very similar, okay? 72% of them had an identical figure or table. So did you notice that? Did anybody have a picture or photograph in your papers? Anybody, the ones that you analyzed. Did you have a photograph that was in both papers? No? Well, sometimes we would look at it, we'd see that there's a picture of, for example, a cell, and in another paper, there was that same picture of the same cell. The probability of two research labs having the same picture is 0. Very bad. So, 72% of them have additional evidence that there was something wrong. Okay? Now, in America, people, when you take a survey in America, where someone asks you, what's your favorite ice cream? So they do that kind of stuff here a lot, because people want to sell ice cream, they have a survey. Anybody know what the average rate for people responding to a survey is? 1 or 2%. So 1 or 2% of the people will respond, you know. The rest of the people throw it away. 90% of the people responded, so they thought this was important. So it was very important. Now, here's some of the things that we found out from the responses. The authors of the original paper, 93% of them were unaware of the other paper that had copied their work. So they had no idea what was going on. Now, of the authors that were on the latter paper, the ones who had copied it, 26% said what they did was okay. There's nothing wrong. 35% said it's bad and I apologize. 16% said I was an author, but I didn't really write any of the paper. And 13% said, am I an author? I don't know. What happened when we sent this out? It was a questionnaire. We didn't accuse anybody of anything, but the journal editors recognized that there was something wrong. So, out of 206 things submitted, so far there have been over 90 investigations where they actually started investigation to compare these things formally. Over 50 of them have been retracted, and saying that this, we've looked at it, we've decided it's plagiarism and inappropriate, and they make that judgment and they retract it. They say, remove it from the information. Just so you know, this number 50 does not include the contributions from one author who had 72 papers retracted as a consequence of our study. Okay, and this was a strange case. Okay, this did not come out from this here. This was an entirely separate thing. What happened was there was a professor who was a chemical engineer. Okay, and he submitted a paper to a journal. That journal reviewer looked at the paper. He happened to be a person who liked using ET Blast. He took the paper that this guy submitted that he was reviewing for a journal, put the abstract in, and found another paper that was already identical to it there. So he reported back to the journal. The journal editor thought it was wrong. The journal editor reported back to the person's campus, and that campus launched an investigation and looked at all the papers that this person had written. Okay? So in 3 years, this scientist had published 72 papers in 3 years. First of all, it's almost impossible. Okay? I have trouble reading 72 papers in 3 years, much less writing them. When they investigated this, they found out that all of his publications, he had simply gone and copied and plagiarized them. So, it did two things. So the first thing is, they're all retracted. The second thing is, it proved that you could use ET Blast to detect this before it happens. So it stops. It's a deterrent for this. And so this guy got fired. Okay. Now, we published a variety of different papers, and this happens to be the activity on our website, on our database, as a function of time from 2008 through 2009. Okay? Now, when we published the original paper on how the search engine works, we got a very small activity. But when we published a paper on how many pairs are identical, we've got about 15,000 users on our database in just one day. This was published in Nature. Then there was a couple of newspapers. Le Monde and Der Spiegel are European newspapers. They had a huge number of people visited after reading the newspaper about this. There was a professor in Harvard who copied somebody's work. He was the chairman of a clinical department. Someone found that in our database. This paper was retracted and covered by Nature News, and so it drove a lot of people to our database to look at that one paper. By the way, this is a guy who, chairman of a department at the most famous medical school in the United States. He resigned his chairmanship and was a professor of Harvard at this time in response to an investigation which told him he needed to be resigned or you'll be fired tomorrow. So he resigned. So it's important, don't do this, okay? We had a couple of other papers in Nature. The ex-vice president of Iran was also an immunologist, and she plagiarized a paper, and people came to our database to look at that one paper, okay, many, many times. Actually, they were looking at all the papers from people from Iran. The interesting thing is we did not discover this, for example, and we didn't discover this. These are users of our database would find these things and report them, and this would happen, okay? The paper I just told you about when we compared 206 papers, that was in Science. Here's the activity. This is when we published it. This was a 2-page paper in the journal Science. The journal Science then did their own study of our study and our methods, and they wrote a 4-page paper about our 2-page paper. So they wrote a commentary about our commentary. So it drove a huge number of people. So that was very exciting. Now, we have some very recent studies that we haven't published yet, but I'm going to show you. One is, when you start comparing the whole paper to a whole paper, papers generally have sections that are introduction, methods, and results. So we actually did this for a large number of papers, 72,000 papers. And in general, the section that is most similar between papers is methods. For the average amount of similarity in 72,000 papers in the method section is only 1%. And you'll expect that. So that's kind of using the same words, right? This is okay. However, we identified some duplicate papers, about 400 of them, that were very similar, okay? Computer analysis there showed that 82% of the introduction, the words in the introductions of these 400 papers were identical, 90% in methods, and 94% in results. So therefore, this is kind of bad, all right? But it tells you a few things. It says that oftentimes the methods parts are the same, and they should be, because people like to use the same methods over and over. That's how you reproduce science. That's good. But they're still unique. This is not very good. So this is something it's in review right now. We submitted it. So highly similar methods, good thing. And however, you would expect the results to be unique. We've now done an analysis of our database. And although the medical literature is increasing at about 700,000 papers a year go into the medical database, new papers, there's approximately, as of this year, 2008, there's 4 per 1,000, or about 3,000 papers that are too similar are added each year. So this is a growing problem. It's not as bad as it was a couple of years ago, but even at this level, there's 3,000 suspicious papers going in each year. It's too much for us to handle. Okay?